We have already set up the project for the splitter. So we have already set up the turbulent energy as well as the forces, side force, slip force, and drag force. Now we're ready to run the simulation, okay, to determine the downforce generated by the splitter. So right click on the title of the project and then run. Okay, so we have to do new calculation, okay, and then run. So this will take several minutes, okay, in preparing the model. All right, so now it's calculating. So from here, this is the total downforce on the car. So you got the drag force, you got the lip force, and then you got the side force, right? So this is the live data, okay? As the air increases in speed, okay? Some more, all right. Okay, now done. So we can check insert flow trajectory to determine whether the airflow is correct. So we tested the car at 200 km/h. So we change this number to 50, right? And then we will use flat arrows for this time, okay? And then we select the splitter, okay? Select this area, this area, this area, this area, right? Okay. And then at the same time, we select also this vane, turning vane, both side, right? Select also this area of the car, okay? Select also the canard. Okay. You want to see only the airflow on what happening, and of course the downforce later on the splitter, and then of course the under of the car. Okay, so this area. So we have already selected under the car and the splitter, and then check. All right, so you notice that the airflow that we can see is all blue, so it means it's only between 11 and 94,950, okay, and 112,114 Pascal, okay. So this is the flow. Now to determine the downforce, we have to insert surface parameters, but before that I want to play the trajectories and see, okay, see what's really happening on the site. All right, so it's really a very low pressure on below, okay. Exiting to the diffuser, but we never select the diffuser yet, okay. All right, so now we are going to insert surface parameters. Insert. So on these surface parameters, we can check instead of pressure, we can use force. Okay, check. So this is the force. So we want to select only the top portion of the splitter. Of course, we cannot really determine the exact value of the downforce on the splitter because the surface area that we can select is only very limited. Okay, we cannot select the entire floor. All right, so this is the area that is being pressed by the air on the splitter. So how much force we can determine it here. So this is the force above the splitter. So we got only 172.7 Newton. Okay, you can convert this one to kilogram. So if you convert this to kilogram, you have to use the gravitational force value per square meter, which is the 9.81. So you need to calculate, because you notice the surface area of this one is only 0.196. It's very small. Okay, so this is the force. Now we can also check the force under the car. So we check. So let's see how much force is under the car. So same thing, insert surface parameter, insert, we have to select also force, and then we select the board beneath the car, including the splitter. Okay, so this area, okay, we select. All right, and then show. So here the force is 1788 Newton, but this is a negative value. If you notice here on the y component, it's a negative 1768.674. So this is the force under the car, so therefore this is a negative value. Okay, so it's a down force, right? It's not a lift. So this one is a great down force because your splitter is uh, directing the flow under the car in a minimum value so that it can create a suction or vacuum. Okay, that's it in analyzing the flow on the splitter.